Hey everybody. So, we've been working with radicals for a little while now, but what we need to do today is rewrite them as a exponent, because believe it or not, a radical is a type of exponent. And so here is the way radicals match up with exponents. If you have the a root of x to the whatever b power is, you could rewrite that as x to the fraction exponent where b is on top and a is on the bottom. So here, just like normal, a is called the index. The index of the radical. And in exponential form, the index is going to be the denominator. Of that fraction exponent. The value of b really doesn't have a special name, but it's just called the power. And it will become the numerator. So let's practice rewriting some of these. The fourth root of x to the seventh power could be rewritten as x to the 7 over 4 power. The 7 exponent inside goes on top. The 4 index in the little corner of that radical goes on the bottom. The next one, the fifth root of x squared becomes x to the 2 over 5 power. Next one, the cube root of x to the fifth becomes x to the 5 over 3 power. Next one, the ninth root of x squared becomes x to the 2 over 9 power. Now the next one, I didn't make a typo and forget to put an exponent on the inside there. This is just the cube root of x, otherwise known as the cube root of x to the first power. So this one would be rewritten as x to the 1/3 power. So anytime you don't have an exponent written down, this is one of those understood numbers in math where it's understood to be a 1. Over here, there's also a number missing, the index. And weirdly enough, it's not 1. This is not the first root of x cubed. Well, anytime you didn't see an index before, like the square root of 4 equals 2, you knew it was the square root because you just did. That's the only root you knew up until this point. So here the index is 2, and this could be rewritten as x to the 3 over 2 power. Okay, I want you to take a couple of minutes and try the next 6. Okay, so we've got x to the 7 over 9, x to the 5 over 2, x to the 3 over 8, x to the 11 over 4, x to the 1 over 5, and x to the 1/2 power. Because there's an understood index of 2 here, an understood exponent of 1 there, the square root of x is the same thing as x to the 1/2 power. So as long as you can put that little number in the corner, the index on the bottom, and the exponent on the inside on the top, you're good. We can also work backwards to write an expression that has a rational exponent back to its radical form. So x to the 2/5 power. The 5, the denominator, that's going to be our index. So we're going to call this the fifth root of x squared. The next one would be the cube root of x to the 4th power. The next one, it's the almost same fraction but flipped upside down, will become the 4th root of x to the 3rd power. Then we've got the cube root of x to the 1st power. Now, you don't have to write that exponent of 1. You can just leave it as the cube root of x. The next one, x to the 5/2 power. You can just call this x, the square root of x to the 5th power. So, anytime there's a numerator of 1, you don't have to write it. And anytime there's an index of 2 or denominator of 2, You don't have to write the index there. On a multiple choice, you would never see it as an option anyway, but it's not wrong. The next one, and you're thinking, wait, what kind of trick is he trying to pull on us with x to the 0.25 power? That's not a fraction. Well, it is a fraction. 0.25 is the same thing as 1/4. And so this will just become the 4th root of x, or 4th root of x to the first power. Okay, do me a favor and try the next three. Okay, so x to the 3/7 power will become the 7th root of x cubed. X to the 22/9 power will become the ninth root of x to the 22nd power. And the last one, x to the 15/14 will become the 14th root of x to the 15th power. Okay, moving on to the back. Be careful of the following examples because they can be simplified. So we want to write them in their simplest exponential form. So what's going to happen here is the 4th root of x to the 6th power, I can go ahead and call x to the 6/4 power. However, that exponent, that fraction, can be simplified, and so we need to do that and rewrite this as x to the 3/2 power. The next one, the 6th root of x cubed, could be rewritten as x to the 3/6 power, but that exponent can be simplified down to 1/2. So we would want to simplify it down to x to the 1/2 power. The 8th root of x to the 12th power can be rewritten as x to the 12/8 power, which can reduce down to x to the, 4 goes into 8 3 times and 4 goes into 12 3 times and 4 goes into 8 2 times, so 3/2 power. Okay, try the next three, please. So, we've got x to the 10/14, which can reduce down to x to the 5/7. And then x to the 6, we've got the square root. Remember, that's an index of 2. So this would be x to the 6/2 power, which actually just reduces down to x to the 3rd power. You don't even have to call it 3/1, just x cubed. And then the 10th root of x to the 6th will be x to the 6/10, which reduces down to x to the 3/5 power. For the next couple of examples, we're going to write it in simplest radical form. So they're already in their exponential form. We just need to be able to reduce the fractions first. So x to the 12/15 would reduce down to x to the 4/5, which we would then write as the 5th root of x to the 4th power. So we reduce 12/15 down to 4/5, and then put that 5 in the index and the 4 on, as the exponent. The next one, 12/9, can reduce down to x to the, 3 goes into both of those numbers, so we can call that 4/3, and then call that the cube root of x to the 4th power. Next one, 2/8 can reduce down to 1/4, so we can call that the 4th root of x, or 4th root of x to the 1st power, it doesn't matter. Okay, take a moment and try those next three, please. Okay, 6/16 is going to reduce down to 3/8, and so that's going to give us the 8th root of x cubed. 8/10 will reduce down to 4/5, so we would call that the 5th root of x to the 4th power. And the next one, 15/20 reduces down to 3/4, so we can call that the 4th root of x cubed. Okay, almost done. This last little section here, we've already got it as a radical, and we want to keep it as a radical, but it needs to be in the simplest radical form. So, what I'm going to do first is rewrite this into its exponential form. The 10th root of x to the 12th power could be rewritten as x to the 12 over 10. But then 12 over 10 reduces down to 6 over 5. And then I can rewrite that back as the 5th root of x to the 6th power. Next one, the 9th root of x to the 15th power could be rewritten as x to the 15 over 9 power. Well, 15 over 9 can reduce down to 5/3, which would give us the cube root of x to the 5th power. The 12th root of x to the 18th would be x to the 18 over 12, which reduces down to x to the 3 over 2, which would give us the square root of x cubed. Remember, if the bottom number, if the denominator is 2, you don't have to write that index of 2. Next one, the 5th root of x to the 10th power. That would be x to the 10 over 5, which goes down to x to the 2nd power, which this one, that actually just simplified down to x squared. And because it's not x to the 2 over something power, we're not going to be able to write it as a radical. I mean, you could call it 2 over 1, but there is no such thing as a 1th root of x squared. That doesn't exist. So the simplest form would actually just be this. Okay, try those next 4 and we're almost done. Alright, so we've got x to the 4 over 8, which reduces down to x to the 1/2, which will be the square root of x. You don't have to write the index of 2, you don't have to write the exponent of 1, unless you want to. Next one would be x to the 12 over 14, which reduces down to x to the 6 over 7, which gives us the 7th root of x to the 6th power. And we've got x to the 15 over 18, which reduces down to x to the 5 over 6, which gives us the 6th root of x to the 5th power. And last one, we've got the 20th root of x to the 24th power. So x to the 24 over 20, that will reduce down to x to the 6 over 5, which will give us the 5th root of x to the 6th power. Which is funny, because that's actually the very first one from this section as well. You can see that when the index doubled and the power doubled, we end up with the exact same radical either way. Alright, thank you so much for watching. Let me know if you have any questions. Make sure you check your Delta Math assignment and have a good day. Bye.